11.1 talks about the traditional parabola. So we already did this section, but now we're going to modify it to add two more properties, or we're going to have to label two more points that they want. A parabola is the set of all points in the plane that are equidistant from a fixed point f called the focus, which is what you have to label, and a fixed line called the directrix. Now, this is the general quadratic. But here in this section, so 11.1, 11.2, 11.3, the parabolas, ellipses, and hyperbolas are all going to be centered at the origin. So this is a note. For now, we're going to be centered at the origin, which means y equal ax squared, or 1 over 4px squared. What is p? The vertex of the parabola. So if I sketch a graph, the vertex of the parabola is the midpoint between the focus and the directrix. So the focus is always embedded inside of the parabola, and on the opposite side is the directrix. The vertex will be the midpoint. This is p units, and this is p units. Now keep in mind, a parabola can never cross the directrix. So, how are we going to do this? We're going to sketch this like we normally do. I solve for y equal x squared over 4. I know how that graph goes. If x equals 0, if x equal 1, y equal 1/4. And if x equal -1, y equal 1/4. It's a bit wider than the traditional. There it is. Done. Now what? They want us to label this focus. Well, we know the focus is inside and the directrix is on the opposite side. To figure out the focus, there's only one way of doing that. You take the quantity in front of the square and you set it equal to 1 over 4p. We're going to do that also in section 11.4 when they do those shifted. So we take the 1 over 4 and always set it equal to 1 over 4p. That's the only way we could figure out what p is. Cross multiply. If p equal 1, that tells you 1 unit above and 1 unit below is the line. So you need to label for me the vertex is 0, 0 in this case. The focus, well, if it's right there, it is at 0, 1. And the directrix is y equal 1 unit below. That's -1. And those you must label for me on every graph. If I look at the second line, now, I know that this parabola opens down 0, 0. If I move 1 to the right, I move 1/8. And I move 1 to the left, 1/8. So this parabola is a lot wider. Missed it by a mile. Missed it again. Okay, I can't see from my hand. There we go. So I know already, well, the vertex obviously is 0, 0 on all of those, but we're going to label it anyways. I know the focus is somewhere in there and the directrix is somewhere up there. So I know the focus is at the point 0 and it's negative. And I know that's positive. I take the number, the quantity in front of the square, and I set it equal to 1 over 4p. Cross multiply. P equal a -2. Now the significance of p being negative indicates that the parabola opened down, but we already know that. So this says 2 units. And I'll label everything on the side. The focus is at 0, -2, and the line is y equal 2. And again, I make sure that those are clear. Those should be very simple, straightforward 3 sections for us. How about this problem? Well, the same deal. I solve for y. I always do. So I'll get y to equal -3 over 2x squared. So I know this is a parabola that opens down. After seeing the top equation, I don't think I need that much space for those. So I could shift the graphs a bit to the right. That's not an issue. Well, I know this is a parabola that opens down 0, 0. If x equal 1, y equals -1.5, and -1, -1.5, like we did back in the days. So this is a sharper graph, no big deal. I know the vertex is at 0, 0. And if I want to figure out the focus is at 0, negative, and the line is y equal a positive, I take 1 over 4p, and I always take 1 over 4p, set it equal to -3/2, cross multiply, -12p equal 2, so p is -1 over 6. So 1 over 6 down and 1 over 6 above. I don't label things on the graph because that colors the graph. I label them on the side. And here they are. And the fact that I'm starting at 0, you could find a lot of shortcuts, but that's going to change once we get to the next section. Now, I look at this problem and I notice this says x equal y squared over 8. Well, I'm not used to x equal y squared, so I have a trick for you. Anytime, excuse me, you come across one of those that you're not used to, switch x with y. I know how to graph this. This is a parabola that opens up, something like that, right? 0, 0, 1, 1, 8, -1, 1, 8. I just did one of those. And I know the vertex is at 0, 0. Now, if I take 1 over 4p, set it equal to 1 over 8, 4p equal 8, p equal 2. So I know 2 units above and 2 units below. I got everything, but that's not my graph. So what I do, I switch those points. 0, 0. The point 1, 8, 1 that I did, I switch x with y, 1, 1, 8. Switch x with y, so, I'm sorry, this was 1, 1, 8. Switch x with y, 1, 8, 1, and -1, 8, and 1, 8, -1. I know the focus, instead of, so the vertex is at 0, 0. The focus, I know, is at 2, 0. And the line, instead of y equal 2, switch x with y, x equal 2. This is a nice trick. I like it. If you have to. Once you get the hang of the sideway parabolas, then you really don't have to do that. But until then, I strongly suggest, instead of missing a problem that's easy, because you can't switch x with y in your head, why don't you just do the other graph and go back on the labeling, especially with shifts. Without a shift, it's not that bad. You can guess what that is. So here again, I know that this is, if y equal 1, x equal 1, 6, -1. I know the graph looks like this. I know the vertex is at 0, 0. And I know the focus is at some positive number. And the line x equals some negative value. And I could take 1 over 4p and set it equal to 6. Cross multiply, 24p equal 1. P is 1 over 24. So P is vertex is at 0, 0. The focus is at 1 over 24, 0. And x equal -1 over 24. You could do that if you wish. That's all good. That's not a problem. Or you could sketch the graph. And again, I'm showing you this in case you're having issues with this. You could sketch a graph of y equals 6x squared. You could say, you know what, 0, 0. If I move 1 to the right, I'll go up 1, 6, 1 to the left, 1, 6. Even though that might seem like a lot of work, but it's worth you doing than you messing the problem up. And I could take 1 over 4p and set that equal to 6. So I'll get p equal 1 over 24 again. So go up 1 over 24 and go down 1 over 24. Switch x with y with those graphs. So 0, 0. The point 1, 1, 6 becomes 1, 6, 1. and the point negative 1, 1, 6 becomes 1, 6, negative 1. I get the graph. Switch x with y. Focus is at 1 over 124, 0, and the line switch x with y. That becomes x equal negative. See, I messed that up. So it's up to you. How do you do this? I really don't need the shift. I don't need to do this, but when we get to the shifted graphs, I suggest you do that because it's a bit annoying in the beginning. Graphing is the easy part, labeling is the hard part. If I look at this graph, so I know this is a parabola that opens, you know what? I don't know why I didn't do that. There. Well, if y equals 0, x equals 0. If y equals 1, y equal negative 1 over 16. Y equal negative 1. So this is a very wide parabola open to the left. The vertex is at 0, 0. I know the focus is at negative some value 0. And I know that directrix is x equals some positive value. I'll take 1 over 4p and set it to equal negative 1 over 16. 4p equal negative 16. P equal negative 4. The fact that p is negative tells you it opens to the left. We already know that. 1, 2, 3, 4. There's the focus. That's at negative 4. And 1, 2, 3, 4. X equal 4. Those are the points you need to label. There's your line. There's your focus. A couple more to make sure that we're seeing this. I'm going to shift this a bit to the right like I did the other ones. I don't know how much space I need, and without the shift, it turns out I could have fit 3 of those, but it's okay. Having more space, it's not that bad of a deal. So here, I'm looking at x equal negative 1/5 y squared. If you're comfortable with this, go ahead and do it. I'm going to assume you're not. So I'm going to go ahead and say, you know what? I'm going to really do all of this work. I'm going to do y equal negative 1/5 x squared. So the graph, I'm going to graph it, even though it's a lot of work, no big deal. 1, negative 1/5, negative 1, negative 1/5. It opens down. Got it. So 0, 0. 1, 1/5. Switch x with y. 1, negative 1/5. So negative 1/5, 1, and negative 1/5, negative 1. I got the graph. Now, I'm going to take 1 over 4p and set it equal negative 1 over 5. So I'm getting negative 4p equal 5, p equal negative 5/4. So 1 and 1/4, right? 1 and 1/4. The vertex is at 0, 0. Focus 0, negative 5/4, and the directrix y equal 5/4. Switch x with y. There's the focus. Directrix x equal 1 and 1/4. And the labeling, which is the most important part, is all right there. The vertex switch x with y. The focus switch x with y. And the line switch x with y. And there it is. The last problem, I know what that is. That's a sideways parabola. That's not that bad. Well, still, the new part. So the vertex is at 0, 0. That's simple, but if I take 1 over 4p, set it equal to 1. That means 4p equal 1, or p equal 1/4. So 1/4 of a unit and the line 1/4 of a unit to the left. There it is. Now, backwards turns out to be easier. They're not asking for a sketch. I'm going to do just a rough sketch to see it. So this is me doing a bit of extra work. Even though they're not asking for this. It says, find an equation of parabola centered at the origin, satisfying the given conditions. Okay, what are the conditions? I have a focus at 0, negative 1 over 8. That tells me the parabola opens down. That means it's y equal negative 1 over 4p x squared. And what's p? P P is 1 over 8. I already put a negative. So y equal 1 over 4 times 1/8 x squared. And what would that be? Negative 2x squared. There it is. Got it. So it's a lot easier to go from the information or from the graph to the equation. How about here? This parabola is centered at the origin, even though they didn't ask for a graph. I'm going to do that anyways, rough graph. The directrix is y equal 1/4. 1/4 of the way is the directrix. If this is the directrix, the parabola must open down. This is also y equal negative 1 over 4p x squared. P is this distance. P is 1/4. So y equal negative 1 over 4 times 1/4 x. It should be negative, but it doesn't matter because we know how this works. So there it is. Done. What if they told me the focus is at negative 3, 0? If they said the focus is at negative 3, 0, 1, 2, negative 3, 0, if this is the focus, the graph must look like this. It is x equal negative 1 over 4py squared. What's missing? P. Well, isn't that P? So x equal negative 1 over, if you put a 3 right there, isn't that 12y squared? The back of the book might write that as y squared equal negative 12x, but you could handle that, right? And what if they told me you have a directrix at x equal negative 1/2? If this is the directrix and the parabola never crosses the directrix, it must open to the right. It's x equal y squared, almost, 1 over 4p x squared. X equal, and what's p? Well, p is this distance. P is 1/2. It's negative, really. Put 1/2 in there. Half of 4 is 2. Oh. I'm so used to writing y equal x squared. Now I gotta adjust. Okay. I can get it not to cross any of those. Here we go. And the last part. Again, they're not asking for a graph. I'm going to do a rough sketch to kind of visualize it. It says, focus on the negative y-axis. So the focus is here somewhere. 10 units away from the directrix. Remember, they did say that the center is at the origin. And this is 10 units away from the directrix. That means the directrix is right there. That means this is y equal negative 1 over 4p x squared, or y equal negative 1 over 4. And let's see how this works. The focus is on the negative y-axis, and it's 10 units away from... If it's 10 units away, doesn't that make this a 5 and this a 5? Well, if this is 5, that's p. Put a 5 right there. Or you could say y equal negative x squared over 20. 11.1, 11.2, 11.3 are going to work out that easily. And that's pretty much it for this section.